Welcome to this series of online seminars about revisiting 10 key papers by the TANTlab that might have been published along the 10 years of existence of the TANTlab. But I have not been for 10 years at the TANTlab. But nevertheless, we've published a number of papers and the situation has changed, and it's a good occasion now to come back to those different papers and talk about it. I think you know the drill. If you're so maybe this is your first time if you're here online with us. Maybe it's not, so you know the drill if you've been here before. If you're watching this on YouTube, you probably have the context from the series of those little videos that we publish. Each of them is around 1 hour long, and essentially one of the authors of one of those papers is going to be interviewed by Matt, who is right here, and Torben or I will be hosting the session. And today, weirdly, I am the host. Torben couldn't make it here today. And I will also be the interviewee because I am one of the co-authors of the papers that we are discussing today, which is the thick machine paper. Link in the descriptions if you're on YouTube. Yes, I think I will leave it at that. And I will give you the floor, Matt, I guess.
All right. Well, thank you very much. Hi, everyone again. So let's start, with the paper. Maybe we can just get a quick high-level overview of the paper. How did it come to be? It's the thick machine, right? So how did it come to be? Where did the idea come from? Let's maybe just start there and set a little.
Exactly. So, so this is a paper published by, written by Munk, Asger, Olesen, and me. And I'm going to say the full title, which is The Thick Machine Anthropological AI Between Explanation and Explication. And I think so if you're new to the paper, if you've not read the paper and you just attend this, then it draws on a notion that is an anthropological notion, a difference made between explaining and explicating. And that's also related to the notion of thickness. So Clifford Geertz, anthropologist, famous anthropologist, he was famously against the algorithm as a way for anthropologists to look into underlying laws of culture, to put it in my own words. And because some of anthropologists would try to find out the algorithm of people's behavior. So this assumes that the people's culture can be made of laws and so on. He was violently against that. And that's because he thought that the job of anthropology is not to explain as in what are the causes and so the how and the why, but rather what is it to explicate, which is to unpack layers of meanings. That's why he was against the use of algorithms in anthropology. And the point we make in the paper using the thick machine, which is like, I actually, by the way, have it with me today. The artifact is here, the thick machine itself. We built this machine on an experiment that we unfold in the paper, where we defend that the way we use the algorithm is rather aligned with explication rather than explanation, which, to put it super shortly, and then we can go into what the paper says, but essentially, and maybe with the words I would use today, if you want to use machine learning and AI to predict, then maybe you are on the side of people who seek the underlying laws that you want to observe. But there are other ways to use machine learning that are not just about producing the most accurate prediction. It can be useful to anthropologists or just to, citizen and journalists in other ways. It can be assigned other goals that can help unpack our own culture. Like the algorithm can be used as a probe to probe our own culture. And even in a situation where it is, in a way that it's not required for the algorithm to understand the culture, it can be a good probe without really understanding it. Yeah, does a temperature probe understand temperature? Maybe not, but if it's a good probe, it's a good probe. So that's kind of the point of the paper. It's at the same time a reflection on algorithm and also a commentary on the question of algorithms in anthropology and the way our more recent algorithms and even more the contemporary algorithm like large language models, for example, are very different to the kind of algorithms Clifford Geertz had in mind when he criticized the use of algorithms in anthropology. So that's kind of what the paper covers.
And also, maybe we can come back to this, but also somewhat of a commentary on the areas of responsible AI related to explainability and interpretability. And I'll come back to that maybe at the end. But just to kind of continue with the foundation setting. So, many would make the argument that you're sort of intentionally turning machine learning on its head, right? And you're sort of, instead of trying to predict, you're looking for these failures, and that's the point of interest. And so talk a little bit about, the goal of repurposing machine learning in that way, and maybe the sort of, historical foundations for why you do that in this paper, but also why the TANTlab seems to do that so often in some of its work.
So first of all, that might not be very clear because the paper doesn't tell the story of the paper, but it didn't come as a surprise to us that failure would be interesting. That failure can be interesting is a relatively common idea, I would say, at least in STS and in science and technology studies, but also in artistic practice, for example. Essentially because failure is a normative notion. It immediately begs the question of who says it's a failure? Who says it's not a success? And this question is at the heart of the notion of repurposing, which I would personally tie it back. The way it came to me is through digital methods and the work of, for example, Richard Rogers and Nortje Mares. Because in this context, for them, it's less about algorithms and more about like platforms, which also include algorithms. I will give you that, but not just algorithms, also the data and the way they use it and so on. For example, to give you a very practical example, vanity metrics, the number of likes, the number of views, these metrics that are here for the industry of marketing. Can we do research with that? I believe that they just face this argument that these are bad metrics for sociologists, that sociologists should probably use a better kinds of metrics that would be the metrics from the state, like census and so on. Those would be more reliable, more serious, more scientific. They might be more representative. And they had to say, no, sure, there are better ways to get data, but then it's going to get super expensive. Can we not use those data made by other people for other people, but can we not use them for doing good science? And then what would it take? Of course, they are biased and they are distorted in some ways, and they cover something that is not exactly what we would like to do, but they are also already there. So maybe we can do more, and maybe we can do different things. So they had to articulate this notion of repurposing. And at the heart of that is the necessity to divert the goals. So those technologies are there for vanity, marketing, whatever. And you have to bend them to have them do something for you. So you have to discuss whether that is first possible. And if it's possible, how do you do that? And for me personally, the even more interesting question is how do you get to learn or become aware of these other ways you could take technology? Because I believe that a lot of those objects, like algorithms and so on, they come with injunctions about how you're supposed to use them. They are sometimes essentialized as, for example, machine learning is essentialized as a predictive machine. And you could also make this argument that we should not use predictive machine learning because predictions are bad or wrong or evil in some way. But then we have similarly to construct the point about we can use predictive machines in other with other goals than accurate prediction, right? So the notion of repurposing was basically already there, except we were working more with algorithms in this case and less with platforms, but it's kind of the transposition of it. So, to land on maybe a more precise answer to your question, we expected that something interesting would come out of the repurposing of a predictive algorithm in this case. That is why we decided to marry an algorithm with the anthropological data, like cultural data, which is, I've not mentioned that, but in the paper, the data that it is about, the data that is actioned by the thick machine, is Facebook comments from Denmark, where people have at the same time used the form of like, that one of the 5 forms of like in Facebook, like love, anger, blah, 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 surprise. And they have also written a comment to another post. So this is the material we work with, which is, has a cultural meaning.
Okay, thanks. So, you went in, repurposing was something, you're familiar with. Nevertheless, you begin working with this data. Did you have a vision in mind of what you were looking for, or were you thinking of more so just marrying up the technique with the data set that you had access to and exploring what could come out of it?
So we had this idea that we could use machine learning as a probe. I think we did not necessarily articulate it that way, but in essence, that was it. And we were looking for cultural things. So I think that the dataset has been downloaded and curated essentially by Anas and Asger for Asger's PhD. So it was exploratory. We didn't have like very precise questions, but the direction was what would be interesting in terms of cultural phenomena that we could uncover in this dataset. And our exploration was qualitative and quantitative. There were some elements of distant reading, like, making a network of extracted keywords or something like this. And there were elements of qualitatively reading some of the posts and so on. Of course, the data is too big for you to just read it. And one of the reasons we decided to focus on those emoji reactions is because they seem to have a cultural significance. They are also, interestingly, I don't know exactly how this came to be, but one of the points that it's precise in the paper, one of the points that is interesting and was interesting to us in the world of digital methods was the fact that on Facebook, in the time span where we collected that data, first Facebook only had one form of like, which was like the heart of the like, or maybe it was the thumb up. And later on, so during the time range we have, it created these 5 different emoji reactions. Maybe it went through a phase with a little bit more, or a little bit less. I don't remember exactly. So this was interesting about the life of the method and people's reactions to that. But ultimately, we decided to just focus on the period, the latter period where we had like the 5 final emoji. Because, and I think that the intuition came from Anas Munk, he had the feeling of this correspondence with the classic example of the wink. That is from Clifford Geertz. I don't know exactly if it was from Geertz or someone else, but the classic example is if people are having an eye twitch, what is it? Is it a wink? Is it flirty? Is it ironic? What kind of meaning does it have? And this is a good example of where you need explication rather than explanation. The explanation is your muscle make your eye, yeah, sure. But what does it mean is a complicated story about which we may not all agree. And it's such a classic example that is really good because it's kind of minimalistic. It's not about the meaning of a long tirade. It's really about the meaning of a small thing. Emoji are such small things. They are relatively minimalistic. You can quantify them easily. They are datafied, and yet they have this inherent ambiguity. ambiguity is also part of the concept that we are always coming back to. We don't always write that in the paper. This paper is not about ambiguity. We've written other papers about ambiguity, but the notion of ambiguity is here because what we describe in the paper as situations that are interesting to explicate, those are essentially ambiguous situations. And those emojis are interesting, ambiguous situation. So I believe that is how the paper grew around this case. Then it was like, what can you do with those emoji? How can you probe the meaning, the cultural meaning they have for the people on Facebook? And what can you do about that? And from there comes this notion that we would harvest textual reactions and emoji reaction by the same person to a given post and try to unpack the alignment of the emoji with the text. Are they both angry? Are they both supportive or something like this? And what could we do about this? And then this became gamified as the arcade machine that's behind me, where people could play by trying to guess the association. So, if you've not read the paper, the idea is that you read a first post written by someone, and another commenter wrote a response to that post, and you must guess by reading their response which emoji they had also used to qualify the initial post. So if they leave an angry text, what was the emoji they left for the initial text? Probably angry reaction, but that's ambiguous. Or rather, sometimes it's obvious and sometimes it's ambiguous.
Okay, thanks. Now, so coming down on, we'll come back to the test itself and some of the methods there again, but in order to think through this, you came up with 3 tests. You had the naive ethnoscientist, the reflexive ethnoscientist, and the interpreter ethnographer, with the first 2 sort of coming down more on the explainable side, the latter 2, right, more on the geared side. So tell us a little bit about how you came up with those 3 tests, what you were trying to demonstrate with those as it relates to the data.
Okay, so basically those 3, so they are, okay, first, any kind of tests where you kind of compete with the AI or involve AI in some way is some form of Turing test. And I would have to say, nowadays we know much more about the Turing test because the naive version of the Turing test is so easily passed by LLMs nowadays, or easily, but it's much more like there is a philosophical debate about the validity of the Turing test and variations of the Turing test and so on. We were a little bit before that, so we mentioned the Turing test because it's inevitable that people are loaded in their mind with these questions when they will read the paper. So there's that. And then if you think of because we were not trying to make a Turing test, but it's a precedent we had to acknowledge. If you try to explain things using this notion of Turing test, we needed to articulate what we're trying to do as opposed to the more classic way we would try to use AI. That's how we had to come up with these 3 characters, but they grew from the need to articulate what we had done. They were not there since the very beginning. I think that the way I see it is that we need to contrast the first and the third ethnoscientist. So I'm going to read them. The naive ethnoscientist is like just anyone who would just try to use machine learning as intended, as a predictive tool. So the naive ethnoscientist would be trying to capture the behavior of people on Facebook. So they would use an algorithm to capture that behavior and reproduce it, right? So in this case, reproducing the kind of emoji people put by reading their text answer. And then what we were trying to do, what our version of the test, which is quite different, is the interpretive ethnographer, but then there is kind of a missing link in between. So that we had to articulate a third position that is intermediary, because we realized that there is a non-naive way to do it that is yet not what we do. So the middle point is the reflexive ethnoscientist. You're not naive in the sense that you don't assume that the algorithm can actually imitate people thanks to the existence of underlying laws of culture, for example. but you will still use it in a predictive way, kind of as a computational ethnographer, kind of. So you would basically try to, how could I put that in simple words? You would try to become an augmented ethnographer with the algorithm. So it is useful to you, you are still in control, but you are still trying to have the algorithm relatively align with the field, align with people's behavior so that you can use it. And then our position, which is the interpretive ethnographer, is using, and just to be clear, I am not rejecting the middle position or the naive position as bad, and our position is as being the good one. But rather, depending on what you want, you may be one or the other of those figures. But I think that the figure we defend in the paper is the most difficult to reach. It requires more imagination in a way. And it's to use the failure of the algorithm as a probe for situations that are interesting to you. So the difference between both the reflexive ethnographer, so the middle point, and the interpretive ethnographer, so what we propose in the paper, the level 3, both of them are reflexive, both of them are critical of technology, both of them know what they're doing. But one is aligned, one succeeds if technology succeeds, the other one succeeds if technology fails. I think this is an idea that I sometimes have a hard time passing on to other people. For example, I would be saying, okay, today we have these large language models. What is a large language model that will be useful to you because it is bad and not in spite of being bad? An example of this is if you want to have a shallow reading of your text, and this is really useful as someone who writes, to have a shallow reading of your text, use a bad LLM. Not only it is less costly, and you spend less energy, you don't have this race to the biggest model that is relevant to you, but also it just works better because the more clever models, they are less shallow. And sometimes what is predictive to you is the failure. So can we find the way the failure is predictive to you? That's the move here. So that's why explaining that move and making it visible required articulating these 3 personas.
Right. Thanks. Now, let's dig in from there into the actual to the technical approach a little bit. And I know you already showed off the hardware device, but so tell us a little bit about not so much the collection of the data, but maybe the sort of wrangling and the prep of it, and then ultimately how folks engaged with it via the actual hardware-based thick machine.
So yeah, so it's first there's this very, very big Facebook dataset, I believe, that so just so that people can follow, I don't speak Danish very well, a little bit better now, but at the time, not at all. So this was really the work of Anas and Asger, who both speak Danish, and Danish native speakers. And the lab, of course, the TANTlab was interested in this. They basically, first of all, the big data set of Danish Facebook was harvested at the moment the APIs were closing. So just before they closed and GDPR came into force and so on, with the kind of the last remnants of the old world where we would use all of this to do social science, we downloaded this data set. That's why there is the cutoff is what it is. And then it was like a treasure trove that we could use in different ways. We've done different things with this. It was at the heart of the thesis of Asger Olesen, who is one of the co-authors. So for this specific project, basically, we had to. So I explained first the kind of research design, right? So we look for something quite specific. The conditions that must be met are that someone so you have an initial post, original post, then a response to that by a person who has also chosen an emoji reaction to this original post. This can be obtained if you make a query on a database. So essentially, we downloaded this information and we stored it in an Elasticsearch engine. And then we could make such query in the Elasticsearch engine and extract all of this. One of the points we defend in the paper is that if you do that, you do not have a balanced volume of different types of emoji reactions. The love emoji reaction is overwhelmingly the most present. So you have a research design, you need to normalize things. We decided to normalize by emoji reaction. So we wanted maximum data. So we took the least present one and we gathered as much as the least present one of the other 4 by randomly sampling the bigger query where we had all the 3 conditions met. So we reduced the data set this way. This was just done through Elasticsearch queries. And yeah, and then there was a little bit of tinkering. So something that we do not spend too much time about in the paper, but still a little bit. Essentially, I would say that the main point of the paper is not really about the choice of algorithm. It's a point that would work for any algorithm. But in this case, we have tinkered with 2 different versions. We had two choices that had 2 options. And we've tried the 4 combinations. The first one is, how do we, so we needed a machine learning algorithm to learn, so supervised machine learning, how to learn the emoji reaction so that we have a model of this. What would be the feature space? Should it be just the words, or should it be something more fancy, like topic modeling? We've tried both. It turns out that topic modeling gives worse results. And then when it comes to having a neural network, so in this case, it's a multi-layer perceptron, to do the learning, do you need it to be like the default small one that is not even deep, or do you want additional hidden layers and so on? For this task, adding layers was not useful. So basically we committed to the simplest one. So no hidden layers, some simple bag of words model, except we have a normalization of the words, which is TF-IDF. Like, essentially, at the end of the day, the most basic natural language processing things you can imagine. And yes, that's it.
Okay. And then from there, you essentially had folks step through, using the actual thick machine. And we mind just describing, for anybody who maybe didn't read it, how you put together the hardware device and how you use that in the actual research.
Yeah. So then the question is, you've got this data set, you've got this model, and then what do you do with that? You want to do some form of experiment, and what kind of experiment? And this is really the creativity of Asger that was at play here. He physically built the machine and so on. So the idea was to have a game that would be stripped out of the context. I also see repurposing in this, right? So it's important that we get the thing outside of Facebook. It's important that you are not doing the experiment within a Jupyter notebook, for example, with a lot of overload or something that looks really techy and so on. We wanted anyone to be able to engage with the game. So we wanted a friendly, fun setting for people to spend the time and the brain energy to actually read the post. So just in case it's not very clear, to play one session of the game, or one session, to do one bit of the game, you've got to read an initial post in Danish. Then you get to read a reaction to this in Danish. And then you get to choose one of the 5 emoji. So the physical machine, I don't know if I can show it here. The physical machine has these buttons, and the buttons are the 5 emoji. Actually, we had this idea of having like 2 players thing, but really the machine you play against the model in the final form of the machine. But so the commands are the 5 emoji. So it's easy to know what to do. So the screen shows you the thing. Under the hood is just a Raspberry Pi that's been programmed with simple interfaces, and then the screen, for the physicality of the machine, is just a normal PC screen has been bought and then stripped out of its frame and glued in the wooden frame that Asger had built. So the machine was physically in the lab for a while, and people could just play the game. The game would be on, and then you can just try to make those guesses. It takes some mental energy to play the game. It's not easy. Sometimes it's easy, and sometimes it's difficult. Sometimes you have no idea. or you hesitate between different things. And this is a very key part of the game for our argument. But it's just to say it's a very cerebral and intellectual game. It's an anthropologist game, sorry.
So now, coming back to maybe some of the bigger themes, and appreciate you stepping us through that. I will say that, it's less common, I think, in our space to have, hardware-based devices used in the research process. So I've always appreciated this paper. But so to sort of bring it back, so essentially we have the three tests. First test in the naive version, you found that the machine wasn't particularly good at predicting. Second test was fairly close, about 1% off, I think, of sort of machine versus human. Third test, obviously you're focused on the failures. And the failures is particularly then where you basically are making the point that because those are the ambiguous situations, that it's hard, in fact, to really make sense of from an algorithmic perspective, that is then the area that we should get re-engaged. And that's the opportunity to really dig in and understand what is interesting about this and to then bring to bear sort of our interpretive lens. Anything you want to say on that real quick before I move on?
So, I have a reaction to the way you frame the situation, because I think that they are not three tests. They are not three different tests. There are three different perspectives on the same thing. So in the sense that the model is what it is, right? The model is the same for the three characters. And you could, the three persona could have three different ideas about how to approach this. But in this instance, there is only one, and you can see the three ways. And this is important to me because it speaks to your imagination as a scientist and whether you are able to understand the value of what you're doing or not. This is something that is really important to me as a teacher, because one of the most frustrating things for me with my students in controversy mapping, for example, an exercise that requires some nuance and some powers of observation and so on, it doesn't require to be loaded with a lot of theory. It requires to pay attention. And some students do it extremely well right off the bat, right? So some are really good at this. But some, they will come to me and say, there's nothing, I have read all this text, all what the actors say, and it's not interesting. And I would read the text and I would find it extremely interesting. So they don't see. What makes you see what is interesting or not? It's kind of a mystery. Some people have the kind of perspective and some people don't have the imagination to take things from a different angle. So basically for me, the naive, so we have this model that is what it is. And the difference between the three characters is not just how reflexive, but if they are able to understand where the value lies. The naive ethnographer wants the value to be in the success of the algorithm in terms of accuracy. And the answer here is the model is not super accurate. The reflexive ethnographer wants the success of the operation to be in the alignment of the algorithm with the people's behavior. So in this sense, it's not a problem that the model is not accurate, because people are also not accurate. So for this ethnographer might be happy to find that the model has the same accuracy profile as people. That's a better way of seeing it, more advanced in a way. But the third version of this, so the interpretive ethnographer, is not interested even in this alignment. It sees even further that the failure can be used as a probe. So basically, this just to make it clear, not for you, Matt, who've read the paper, but more like for people who don't know the paper well. Essentially, it's actually quite intuitive that most of the time situations are banal and they don't require the entire extent of the skills of an anthropologist to be unpacked. Most of the time people are just, I love this, they say I love this, and they love. Or I say this is fucked up, and then they say angry. Most of the reactions are like this. but some reactions are ambiguous. And it takes this kind of reflexivity to understand that maybe in some circumstances, those are the ones that you would be interested in as a scientist. And then not only it's necessary that the model is aligned with people, because it kind of captures something about people's behavior, but even underneath, it captures the inherent ambiguity of certain situations. And that is the probe you want to act on. It requires kind of a quite precise idea of what you're doing as an anthropologist, what has value in this system. You know, it really instrumentalizes the algorithm in a way that is not what people who devised the algorithm had in mind. So the reason why this third version is less accessible to the normal person as a perspective, so not as a test that we think of, but as a perspective that anyone could have, is the fact that it is so at odds with what machine learning is said to be made for. It requires you of letting go. It requires you to let go of the injunction to use machine learning as a thing that should be good at predicting. And this takes imagination. How do you find that? I don't know. We were loaded with this STS culture that helps you see that, but yeah.
Yeah, no, great. And so we should probably open it up to questions, but just one last one. You know, this paper was written prior to LLMs blowing up on the sort of world stage.
Exact.
But, you know, you may have been playing with earlier models. How might you do this different today? And would you expect, you know, any different outcomes, or, you know, would you frame it differently? Any changes to how you would approach it?
That's a very, very good question. So first, let me say, I think it's quite obvious. The situation now, it makes that kind of paper even more relevant. But it's complicated. It's complicated. One of the reasons why it's complicated is because I want to pay homage. Like you have me on record saying this. I'm not going to say that often. Kudos to OpenAI for inventing the chat format. They made the repurposing. And this is, if you read closely the papers, to me it's kind of hilarious, retrospectively, to read the GPT-2 paper, how they talk about what GPT-2 is capable of doing. They have kind of an old style, even though GPT-2 is this is basically a worse GPT-4o or whatever. It's like the same thing as what we have now, just it doesn't work as well, but it already works. So it doesn't lack anything. It's just lower quality. And yet when they publish the paper, they talk about it in a way that is very weird to us nowadays, that we are in this new world, and the way they talk about it is still this old world, what they consider as, because they are obsessed with prediction. And then suddenly the chat format comes and everyone is using this generative AI in a completely different way, where no one is thinking about the powers of prediction, even though the entire generative thing is by generating predicted tokens. But then prediction is not on the radar of people who use ChatGPT. They just speak to it and do complete. Then the questions become, does it know how reliable it is in the computation at certain tasks, at knowing, at counting, at summarizing, at assembling knowledge, at whatever tasks, and you can benchmark them at this. And none of those tasks is predicting. So this was invented by OpenAI, I believe, or maybe someone else had the idea and they took it. But that was a fantastic magic trick. We need to do it as well. Maybe the lesson here, if someone were to kind of try to redo a similar paper, and also it depends on what do you mean by similar. But I think that the best similar way would be by cultivating algorithmic imagination for the social sciences and humanities, right? That's how I take this paper if I take a few steps back. And so think about how we have normalized the behavior of ChatGPT. Now we think of generative, we also have this experience. So now we think of generative AI as this thing that speaks to you and writes and so on. Also, just to be clear, it's not just that you generate all those tokens, it's the fact that the ChatGPT and its also alter egos, Claude or whatever, they speak like you are incentivized to think of them as a single voice, even though that's deeply not what they are. And we could have dramatized them in a different way. So there is a lot of room for you to repurpose, for you to have more imagination, to bend that technology in other ways. And the question for me is always, how do you cultivate your own imagination? How do you see through the magic trick? But the important thing, and that's why I wanted to say kudos to OpenAI, is that the industry does it as well. It's not us scientists who have this imagination and the industry is like stupid and going the same way. No. They also are really good sometimes at this game. What I want to say here is, let's not be in the passenger seat, because those innovations are lying in those repurposing as much as in improving the technology and at a very pragmatic and level, more performance, more reliability, more power efficiency, bigger token windows. Yes, all of this is true. But these paradigm shifts from BERT to ChatGPT, they are shaping what we can do with those tools. And we could perfectly well have had this idea ourselves, but we didn't. So let's not normalize what the industry pushes as goals to us. So yeah, that would be the obstacles we meet if we were trying to do a similar paper today. Our imagination is loaded in a very different way.
Right, thanks. So as always, we'd like to open it up to questions from anybody else. Anybody, feel free to jump in, raise your hand. All right. Well, I will continue on if nobody has questions today,
Okay,
but David, go ahead. Yeah, David.
Sorry, I've just been on Teams all morning and not not Zoom, and lost where every button was. I had a particular question about how you set up the experiment with the human players, because you talk about how you've had to normalize the data, but the participants, the human participants in particular, they exist on and they probably interact with Facebook, and they've seen and participated in similar emoji responses. So they have maybe some type of heuristic that they would also use the love emoji more than often. And when you look at the predictions, the love emoji has a massive tendency there. Do you think that, did you give them information about how you'd normalized before? Okay. So are they actually making their prediction based on different data then to what you trained the machine learning model on?
I think we told them, I believe, I'm not absolutely sure. But so first, when you launch a session, there was an introductory text. I don't remember exactly what was in it, and it's not in the paper. Second, most of the people who used the machine were from the lab. So we have prompted them, we have explained them a little bit, we gave some context. This is definitely some context that is relevant, because your expectations should be that each emoji is represented at the same time. Did we actually say it? I believe we did, but I am not entirely sure. Good, very good point.
Anybody else? Jonathan, I think you came off mute.
I was trying to figure out how to raise my hand. Mathieu, I'm curious, since LLMs have really exploded after your paper was published, how has your paper influenced how you use LLMs both for your research as well as in your personal life?
So for me in particular, that's your question, right? First of all, the paper is a symptom of deeper a deeper affliction that's been with me all along. And LLMs have been extending this, right? So maybe it's not the paper that is necessarily the cause, but rather what motivated the paper to be written keeps being relevant, right? So I would say going back to this question of imagination that is really at the heart of the things I think are important. When LLMs came, and also, so maybe just to give some details. First, generative AI arrived with image generation. It was, I remember showing the lab during a lunch break, a disco diffusion. And using disco diffusion at the time was kind of the semi-esoteric thing where you would have to try to spawn the Google Colab with the right kind of GPU. You would have the T4 if you're not lucky, and then you would have the, what was it, A1 if you were lucky. You had to re-roll it a few times. You had to, restart the machine when you launched the launch. It was kind of weird. And then it would generate those images. It would take hours if you wanted decent quality. It was before Stable Diffusion, so we didn't know yet how to optimize that well. It was like black magic. And people in the lab loved to tinker with this. And it was a little bit unbelievable. And there was BERT already, but BERT was not, a transformer model for text. It was used by machine learning specialists, but I didn't really use it. I was just happy with other techniques. So I didn't need that. It was there, but no one had the idea to do similar things with BERT, even though, to come back to the precedent point, today you can go back to the original BERT and treat it as give it the chat assistant dramatization. It works very well. But so we've lived with BERT for, 3 years, and no one had this idea. Retrospectively, it was there, and no one saw it. If you can go back in time, maybe instead of betting on the right winning sports team, you just get this idea and you go back to the beginning of BERT, and then you create OpenAI before OpenAI. Anyways, this paper is after, it's written at the moment where we have this disco diffusion image generation moment, and it starts democratizing. Midjourney is arriving, and people can do that online on Discord or whatever. And basically, the ChatGPT moment is November 2022, and the paper is from 2022. So it's just a moment it gets. And the question comes differently for image generation and for text generation about how do you help people see under the hood. I think in some ways it's more obvious what's wrong and what's right with image generation. One of the ways that this work forced me to take certain things more seriously is how can I make an experiment that my students can reproduce with text, so with ChatGPT, so that they can see the issues and so that they can, by their own practice, think differently of technology. And one of the things you can get from anthropology for this is not from Clifford Geertz, but it's rather the notion of, it's from Garfinkel, it's the notion of bridging experiment. We've worked with that, with Anna's Munk on this. We try to devise bridging experiments with LLM. So instead of going along with ChatGPT to be friendly and so on, how can you try to break it? Jailbreaking is one way, but there are other ways. And we've been interacting with the students to try to have them build their own bricks for critical thinking, drawing on those anthropological notions.
Next question. Sorry.
Hi, can you hear me?
Yes, we can.
Okay. My audio wasn't working on my computer, but okay, kind of in the same lane. And also you kind of mentioned about how you were using, a more basic LLM to use the surface level understanding. I was just wondering from like a very practical sense, can you give any other examples of like unintended uses of LLM that could be helpful in STS research? Like
Unintended, there are many, I don't know. all of this is a spectrum, and it also depends on what your expectations are. But for example, LLMs are very good for generating. You can think of many tasks as a generative principle. So, creating options, and then a selection principle. There is a way where you ask the model to make the selection for you. But I think that most of the time it's just more useful to ask for a generation. And one of the things I do really often is I ask for the elephant in the room just to double check for things that are really outside of my area of expertise if I have missed anything obvious. The LLMs are not good enough to let you know if you've missed something deep, but something obvious they are. And sometimes that's what you need. So for example, you could say, okay, what are the 5 key concepts in electrobiology? I'm not even inventing the field. I have no idea what I'm saying. But you have a vague idea of what the field is about. You ask for 5 keywords, and then you can double check that there is nothing really unexpected. If there is, that's why you should not keep asking the LLM. Then you have something to Google, and you have to do your own legwork. But and there would be even more ways. Another way is to use LLM as embodiment of what is the mainstream ideas, right? So if you have no idea how people conceive, like what is the layman's understanding of the notion of multiplicity, which is so common in STS. But do they think multiplication? What does it mean for someone? So you could say, okay, explain to me multiplicity. You go to a basic model and you ask for this. It's a little bit the same idea as a shallow tech, but it's not about depth. It's more about when things have different meanings in different niches, the LLM will often be middle of the road. That's useful as well. Give me your examples.
Yeah, I don't know if can I follow up or?
Go ahead.
Yeah, so I guess I was more looking for things that were like, because I would kind of just, what you described is what I would like know to use it for. But you also were saying that you're using it to help as a method for students to think critically about certain issues. I was just curious if you had come across any uses of them that like aren't obvious. Like it's because you're saying.
Well, for this, take a look at one of my papers that I wrote with Eric Bora from Digital Methods Initiative in Amsterdam. The paper is in Sociologica is called Unknown Unknowns in Knowing Machines.
Yeah.
But basically what we do in this paper is that we measure self-consistency in LLMs, right? So what we do is we ask the small variations of the same question, which is in this example is like, when was some person born? Like, when was Isabel Stengers born? Give me a date. And then we ask in like 32 different ways that are all equivalent, but sometimes there's a comma, sometimes there's a capital something, small variations, like perturbations as we call them. And then we measure the output. And one of the things that is not what the typical person would necessarily think of doing, first, we do not ask the model if they are self-consistent, which the model answers to, but it doesn't match what it actually does. The same way a person is not really a good observer of their own behavior. If you ask people what their behavior is, they will let you know one thing, which is not what they actually do. So that's, the LLMs are the same. But also, when you measure self-consistency, you find that self-consistent answers tend to be better, but not necessarily, which is also weird. So some models are self-consistently wrong, and sometimes they are inconsistent. In their inconsistency, they have a good number of good questions. But what is the takeaway here? We could use that to improve LLMs, which is certainly one way to go. It's kind of more the Eric Bora wants to do that. But what I got away from it is that we can make an experiment where the students do it, and then they realize that when the model is confident, it doesn't mean it's right, but you have to test it. So you have to be adversarial to the model. So, being adversarial to the model, we go back to the notion of a bridging experiment. But bridging experiment is a good example of something that is unusual. It's unnatural. It's uncomfortable even for you.
Thanks. And David, take yours, and then that probably will take us right to the end. So,
just a small question I've been thinking about synthetic agents lately, and the understanding of this multiplicity of voices in an LLM, not a singular voice, how I could leverage that and linking that with this paper about the explication. And do you think there's a frontier here where we can use LLMs to, you're saying it's good to check basically the most common or obvious type of misses that you would make? Do you think we're getting to a point where we might be able to use these for explicating from multiple angles? And could those angles be situated? Because obviously, if anyone's an ethnographer, they have their own background and perspective that they're bringing to their explication as well. And do you see there's a benefit, or are we just getting too much into the weeds and the nuance of having 1,000 different ethnographers reading the same situation and trying to explicate it? And how helpful would that be?
So I want to not answer your question. I want to take your observations, but take them somewhere else.
Okay.
I believe, as often, we meet a problem and we are tempted to try to fix it. And I would like to say, okay, maybe it's not a problem and it's not something we should fix. I think that's something that is really interesting in the kind of intelligence that is not exactly intelligence, but it's still intelligence that we have in LLMs. And it's the fact that it tells us it opens new perspectives on who we are. And what I find interesting in the meaning on top of meanings, on top of meanings, on top of meanings that motivates this notion of explication is how do we think ourselves of what it is to mean? There is a very functionalist take on this, which would be our brain, the hypothesis of, how is it called in English? Mentalise. We have a mental language where meanings live, for example, and then, so inside of you would be real representations or, your inner world mimicking or mirroring the outside world, and that would be the meaning. Does your meaning inside match the outside? And yes, language is an imperfect mediation, but kind of it's still inside you. What if it's not the case? What if there is no meaning, no single meaning living in even any one of us? Maybe Getz is right in a deeper way at the cultural level, but maybe at the individual level. And we were not able to understand that something could be meaning things without a single meaning being living somewhere. The same way we could not conceive ant hills, ant colonies as being intelligent without having a queen. And the same way we couldn't think of a system or a being able to articulate very fluent language without having thoughts. And yet here we are. Large language models do not have thoughts in the sense we have, and yet they speak. The same way, maybe meaning is performed in a way that is very different. I will paste it in the chat, the name of a researcher called Ilan Baron-Holtz. His thesis, which I think is just wrong, right? Just to be clear, is that we think like LLMs. But it's a very useful hypothesis. I think there's a lot of truth to it. I think it's ultimately wrong. But I think he's right to point that maybe we function more like LLMs than we are comfortable assuming. We like to think of ourselves as the homunculus of rationality being inside, and then what we speak is a translation of our inner thoughts. But maybe a large part of us is just generating language that is loosely related to many things. And I think there are a number of things point into that direction. So there's some truth to this, right? So I think that's the direction I would go with the notion of explication. Is explication not actually closer to the truth of meaning than explanation?
Great. Well, and with that, we probably should wrap up for the sake of time.
Thank you very much to everyone. Thank you for your questions. Hope to see you next time. Stay tuned. And yes.
Thanks all.
I take the last word as the host. Have a nice day. See you next time.